गुड मॉर्निंग स्टूडेंट्स। 5 मिनट वेट कर लेते हैं, सभी लोग ज्वाइन करेंगे फिर स्टार्ट करेंगे क्लास। अभी तक जितने लोग प्रेजेंट हैं अपना अटेंडेंस एलएमएस पोर्टल पे So let's start our class. I think module 4 तक complete हो गया. There are only 2 modules left. We will study module today. We will start the module 5. Okay. That means electrical machine का सारा टॉपिक क्लियर हो गया, कंप्लीट हो गया. न्यूमेरिकल के साथ न्यूमेरिकल में मैंने दिखा दिया था कैसे क्या करना है डीसी मशीन से रिलेटेड, इंडक्शन मशीन से रिलेटेड. नाउ वी विल मूव टू द मॉड्यूल 5 पावर कन्वर्टर. मॉड्यूल 4 तक कहीं किसी को दिक्कत? Is there any problem till module 4?
सर वो प्रीवियस क्लास में न्यूमेरिकल करवा रहे थे सर, उसका एक और करवा देते तो प्रैक्टिस हो जाता.
क्या रंजन?
सर प्रीवियस क्लास में न्यूमेरिकल हो रहा था ना सर?
मुझे याद नहीं कौन सा न्यूमेरिकल था वो.
डीसी
क्या बनाया?
एक हुआ था सर, और एक हुआ था उसमें उसमें एक दो करवा देते सर, प्रैक्टिस हो जाती.
अच्छा, डीसी मशीन से रिलेटेड.
हाँ हाँ हाँ.
अच्छा ठीक है, हम करवा देंगे एक दो न्यूमेरिकल. और कुछ? ओके फाइन. देन वी विल मूव टू द मॉड्यूल 5. इस पे न्यूमेरिकल करवा देंगे. चलिए देखिए. Construction working torque speed characteristics, speed control of excited DC. We were doing the numerical on this topic in the last class. कुछ ज्यादा नहीं है, बस एक फॉर्मूला, दो फॉर्मूला बेस्ड रहेगा उस पे न्यूमेरिकल. डीसी मशीन में दैट इज EAN 5PZ/60A उस पे, और एक टॉर्क इक्वेशन है K5IA. वो दोनों पे बेस्ड ही आपका न्यूमेरिकल है. जो वोल्टेज इक्वेशन है सर्किट डायग्राम का, इसका डीसी मोटर कंपैरिजन के लिए V इक्वल टू EB-IA. दैट इज द थ्री न्यूमेरिकल बेस्ड ऑन विच न्यूमेरिकल कैन बी परफॉर्म्ड ऑन द डीसी मोटर. वो तीन जो आपका फॉर्मूलाज है जो लास्ट क्लास में पढ़ाए थे, उस तीन पे ही बेस्ड सारा न्यूमेरिकल बन सकता है डीसी मोटर का. उससे ज्यादा कुछ नहीं चाहिए. बट नेक्स्ट क्लास में हम उसको करवा दें. Now, today's topic is our power converter. Normally, power converter topic is related with your power electronics. मतलब जहाँ पर electronics component use हो जाता है, that is mainly the sense of your power converter. Power नाम से ही पता चल रहा है, this is power converter that converts the electrical energy of one form to another form. Or you can say just isolate the one circuit from the other circuit in your DC part. नॉर्मली जैसे हम ट्रांसफॉर्मर में क्या पढ़े थे, ट्रांसफॉर्मर में जैसे एसी के लिए एप्लीकेबल है, ये आपका वोल्टेज रेगुलेशन करता है, हायर वोल्टेज टू लोअर वोल्टेज और लोअर वोल्टेज टू हायर वोल्टेज डिपेंडिंग अपॉन द नंबर ऑफ टर्न्स. तो उसी तरह आपका जो जैसे ट्रांसफॉर्मर वन प्रिंसिपल था एसी के लिए, फैराडेज लॉ ऑफ इलेक्ट्रोमैग्नेटिक इंडक्शन, उसी तरह आपका जो इलेक्ट्रॉनिक्स में, पावर इलेक्ट्रॉनिक्स में ये एक पावर कन्वर्टर यूज था. पावर कन्वर्टर यूज mainly हम लोग को under power converter topic we have to study the DC buck and boost converters, duty ratio control. These are two main important things. Single phase and three phase voltage source inverter and sinusoidal modulation is not very much important for you, but I will show you some diagram of these two things, that is single phase and three phase voltage source inverter and sinusoidal modulation. ओके. मेनली वर्किंग प्रिंसिपल इसका जानना है, बक और बूस्ट का कन्वर्टर का, और ड्यूटी रेशियोस कंट्रोल कैसे. it is written DC DC buck boost converter. The DC DC means input will be DC as well as the output will be DC. तो यहाँ पर डीसी इनपुट और डीसी आउटपुट देने का मतलब क्या है कि जैसे एसी में क्या होता था ट्रांसफार्मर में, यहाँ पर एसी इनपुट रहता था और एसी ही आउटपुट रहता था. दैट मीन्स दिस इज conversion of AC from one circuit to another circuit, or you can say from higher value to lower value or lower value to higher value. Similar kind of things occurs for this DC DC converter. This is also named as DC DC converter. DC DC converter is also named as your chopper. This is also named as your chopper. Now DC DC converter में क्या है कि इनपुट भी DC है आउटपुट भी DC है. तो इसका यूज क्यों पड़ा? Why we use DC DC converter? Just to regulate the voltage of current in the output side, depending on the application, whether we required a higher value of DC output voltage or lower value of DC output voltage. That means the thing of power converter or DC DC chopper is to convert one DC from value to another DC value. Now, for the buck and boost converter, as you know, boosting means to increase the value. Boosting means हम लोग कहते हैं ना कि मोटिवेट करना या फिर कहीं भी गेम चल रहा है तो मोटिवेट करना. दैट इज मोटिवेट मतलब क्या है? यू कैन इंक्रीज द एनर्जी लेवल ऑफ द पर्टिकुलर थिंग. That means here you can say that for the DC DC boost converter, you have to increase the level of voltage or current. Okay, that is your push converter. And just like opposite, the buck converter is called to decrease the value. That means जैसे ट्रांसफार्मर में नंबर ऑफ टर्न्स पे डिपेंड करता था कि वो स्टेप अप हो रहा है या स्टेप डाउन हो रहा है, उसी तरह यहाँ पे में आपका डिपेंड करेगा कि आप हायर वैल्यू अचीव करना चाहते हैं लोअर वैल्यू अचीव करना चाहते हैं. इन दैट सिनेरियो, if you treat this DC DC converter as step down thing, then it is known as buck converter. And if you treat this as a step up converter, the DC DC step up converter, then it is named as your boost converter. Now depending upon the property, this DC DC converter or chopper is divided into three types. First one is buck converter, buck converter. Second one is your boost converter, and third one is buck and boost converter. Okay, तो DC DC कन्वर्टर या चॉपर में आपका तीन सेक्शन होता है. पहला एक स्टेप अप converter, or you can say boost converter. Second one is step down converter, or you can say buck converter. And third one is the complex part, that is your buck boost converter. That is not as buck and boost converter, that will be buck and buck boost converter. And नहीं आता कुछ. First buck converter, second boost converter, third buck boost converter. Now we have to see all these three converters one by one. Okay, I will show you some YouTube videos so that you can understand very easily what is buck converter and what is the working principle of your buck and boost converter. Then we will see some duty ratio control. कि duty ratio control कैसा होता है? Duty ratio control एक switch होता है. आपका जो working principle है, let us say, so this is the mainly thing of the diagram of your power converter. That means here DC1 और DC आउटपुट जा रहा है. यहाँ पे अगर क्या शो किया कि DC1 से DC से AC कन्वर्ट कर रहे हैं तो इसका नाम आ जाता है इन्वर्टर. बट AC से DC की तरफ कन्वर्ट कर रहे हैं तो उसका नाम आ जाता है रेक्टिफायर. जो कम्यूटेटर सेक्शन में हम बताए थे इलेक्ट्रिकल मशीन में DC में कि कम्यूटेटर कैन वर्क एज ए इन्वर्टर एज वेल एज द रेक्टिफायर. दैट मीन्स इट कैन कन्वर्ट DC into AC as well as AC into DC. Now here from this diagram you can see that when you convert DC to AC part, then it is named as inverter, or you can say AC to DC part, then it is named as your rectifier. But when you convert DC to DC or from DC to DC, then it is named as your chopper. ठीक है. अब यहाँ पर AC से AC कन्वर्टर क्या है कि यहाँ ट्रांसफार्मर यूज होगा कब? जब फ्रीक्वेंसी कांस्टेंट रहेगा. बट जब फ्रीक्वेंसी वेरिएबल रहे तो अगर AC टू AC कन्वर्जन हो रहा है तो उसका नाम क्या आता है? साइक्लो कन्वर्टर. ओके, सो ये एक सर्किट डायग्राम, ये एक्चुअल सिमेट्रिक डायग्राम है so that you can understand easily when you convert one form of electrical energy, one form of electricity into another form, then it can be named by the different names. So if you want to take the screenshot of this thing, you can take it simply. Just you have to remember this thing. तो हम लोग को यहाँ पर पढ़ना है DC to DC, that is chopper. We have already completed your transformer part where the frequency was constant, frequency and number of turns was constant. So this is your transformer when you convert AC to AC. इन्वर्टर और रेक्टिफायर के बारे में हम लोग को पढ़ना नहीं है, जस्ट वी हैव टू नो द योर इन्वर्टर कन्वर्ट्स डीसी टू एसी and rectifier converts AC to DC. As in the electrical machine, we have studied it, the both conversion. Yes, Kanaya?
Sir, inverter and rectifier both are commutator.
No, commutator can work as a both inverter as well as the rectifier. That means it can convert DC to AC as well as
Yes, sir.
AC to DC.
AC to DC. Okay, sir.
Depending upon the application, whether it is required for DC motor or DC generator.
Okay.
ठीक है?
Yes, sir.
क्योंकि जो EMF जनरेट हुआ था डीसी मशीन में हम जो पढ़ा रहे थे, तो उसमें देखे हो कि जो जनरेशन पार्ट है वो साइनसॉइडल था, साइनसॉइडल फंक्शन, बट यू हैव टू अचीव द आउटपुट एज योर डीसी. एसी से डीसी में कन्वर्ट करने के लिए आपको कौन सा कम्यूटेटर यूज हो रहा है? तो एसी से यहाँ पे कन्वर्जन, एसी से डीसी अगर कन्वर्ट कर रहे हैं तो रेक्टिफायर की तरह काम करेगा फॉर द योर डीसी मोटर. बट अगर इलेक्ट्रिसिटी इनपुट है और आउटपुट चाहिए आपको मैकेनिकल, देन इट विल वर्क एज इन्वर्टर, क्योंकि एसी इनपुट जाएगा. किसी भी अगर लाइन से कनेक्टेड है तो इनपुट एसी से कन्वर्ट करके आपका डीसी में कन्वर्जन करना है, तो वो इन्वर्टर की तरह काम करने लगेगा. ठीक है?
यस सर.
ये एक सर्किट डायग्राम है, सिमेट्रिक डायग्राम है. यू कैन कैप्चर द स्क्रीनशॉट ऑफ दिस सिमेट्रिक डायग्राम. So mainly we have to study this part, DC to DC part. Now it can be, you can see here, a DC-DC converter will have three types, that is buck converter, boost converter, buck boost converter. Okay. Now here you can see that boost converter is step up converter. It is written in red, that is, it is your step up converter. That means it increases the level of the voltage from low level to higher value. Okay. This is boost buck boost converter. Buck boost converter mainly inversely होता है. जब इनपुट लो होगा तो आउटपुट हाई होगा, और आउटपुट लो होगा तो इनपुट लो होगा तो आउटपुट हाई होगा. So you can see here in buck boost converter, the output can be maintained higher lower value, which depends on the source voltage. Okay. When the source voltage is high, then the output voltage is low, and source voltage low, then output voltage is high. So mainly it can be said that it works as a complex converter. That means when you require a higher value of the output, then the source voltage must be at lower value. And if you require a lower value of output voltage, the source voltage must be at higher value. So from there, you can see that working principle of boost converter depends upon the two things. अच्छा, वर्किंग प्रिंसिपल हम एक वीडियो शो कर देते हैं, उससे आराम से पता चल जाएगा. फर्स्ट लेट मी शो यू योर द buck converter. Actually this thing is hanging. Okay, first we will see some buck converter working principle.
Step down AC voltage, we use a To step down AC voltage, we use a transformer, but how do you step down DC voltage? We use a buck converter. What is a buck converter? In this video, we will be exploring the design process and working of a buck converter, which is used to lower the DC voltage efficiently. If you have a source, let's say DC, and a switch that is turned on and off periodically, you get a PWM signal. The amount of time a digital signal is in the active state relative to the period of the signal is called its duty cycle. If the switch is on for a long duration, the duty cycle increases, and if it's on for short duration, the duty cycle decreases. Now, if you calculate the average voltage of a cycle, with duty cycle 50%, it's half of the input voltage. That is is, we have reduced the voltage from 12 volts to 6 volts with just a switch. For efficiency reasons, we will replace it with an electrical switch or a MOSFET. This MOSFET is controlled by a PWM signal. How the PWM
This PWM is called named as a pulse width modulation. That is the last topic of this chapter that we will discuss in the last. This PWM means the pulse width modulation. Maybe आप लोग को ये नहीं मालूम है what is PWM. PWM just like a sinusoidal modulation type. ठीक है. Just you have to remember the working principle how the buck converter works. Similarly यहाँ पे जैसे source voltage दिया हुआ है, source voltage में यहाँ पे load लगा हुआ है. This is अच्छा यहाँ पर पहले एक switch था. First it was your switch. तो स्विच यहाँ पे PWM जनरेट करने क्या है कि फ्रीक्वेंटली अप एंड डाउन होता था. तो ये अगर ज्यादा स्पीड से ऑन ऑफ होगा देन ड्यूटी साइकिल विल इंक्रीज. ड्यूटी साइकिल क्या होता है, वी विल डिस्कस दैट थिंग आल्सो. अगर ये स्विच काफी स्लो मूवमेंट करता है, काफी टाइम लेके करता है, देन ड्यूटी साइकिल विल डिक्रीज. बट इसका एफिशिएंसी और एफिशिएंसी रेट काफी लो होता है सिंपल स्विच का. So we have to replace this simple switch with the solid state device. Solid state device is mainly the electronics device which is mainly used to switch on or off the signal. Okay, so that's why we have used, instead of this switch, we have used a MOSFET type signal, or you can say transistor. Okay,
state relative to the period of the signal is called its duty cycle. If the switch is on for a long duration, the duty cycle increases, and if it's on for short duration, the duty cycle decreases. Now, if you calculate the average voltage of a cycle, with duty cycle 50%, it's half of the input voltage. That is, we have reduced the voltage from 12 volts to 6 volts with just a switch. For efficiency reasons, we will replace it with an electrical switch or a MOSFET. This MOSFET is controlled by a PWM signal. How the PWM is generated and controlled will be explained later in the video. But this is just the amplified PWM signal and it has high voltage peaks.
As you can see, यहाँ पर जो टाइम पीरियड है और जो गैप है ये हमेशा सिमिलर है,
To smooth this, we add an inductor in series voltage peaks. The amplifier explains how the
तो जो
MOSFET
गैप बन
is
रहा है यहाँ पे लोड के अक्रॉस जो साइकिल बन रहा है, दिस इज अनदर टाइप ऑफ योर वेव फॉर्म. ठीक है, यहाँ पर जो गैप बन रहा है दिस इज कॉल्ड योर टाइम पीरियड, और यू कैन से पर्टिकुलर एक अगर यहाँ से स्टार्ट करके इस जगह से मान लो लेटर से it will start, the signal starts from this point to this point. Again the signal repeat itself by the same identical thing. So you can see here the time period is equal for the all the signal. ठीक है, तो टाइम पीरियड का वेरिएशन से यहाँ पे एम्पलीफाइड मतलब क्या है, इसका जो मैग्नीट्यूड लेवल है वो इंक्रीज कर गया, whether it is in angular function or magnitude function. So here we can say that the magnitude of the amplified version of PWM source is increased. That's why this is named as your amplified source. Okay, यहाँ पर ये waveform इसको कहते हैं square waveform. You can say for long duration, if you see that, this is called your another type of waveform, that is impulse, or you can say there is another thing. Normally this is named as impulse rated value. Okay,
controlled by a PWM signal. How the PWM is generated and controlled will be explained later in the video. But this is just the amplified PWM signal and it has high voltage peaks. To smooth this, we add an inductor in series with the load. This is an inductor. Inductor wants to keep the current constant through itself, and for that it will instantly change the voltage across itself. As the switch closes, the current starts to flow. To resist this flow, the inductor drops the voltage at another end to 0, creating equal and opposite voltage to the battery. This is possible due to the magnetic fields which are generated in the inductor. but it can't resist it for a long time, thus the current starts flowing and voltage at the other end starts rising. Also, the inductor starts storing the energy in its magnetic fields. After some time the magnetic field stabilizes and the inductor will act as a closed switch, allowing maximum current to flow. Now, if you open the switch, then there is no source to supply current and thus current starts falling. But as you know, current through the inductor cannot change instantly. Hence, now the inductor acts as a battery supplying current, but it slowly runs out of energy. As this end is open, the electrons accumulate here, creating a high negative voltage. This may damage the components. Thus we add a low voltage drop Schottky diode to create a path for electrons. But the voltage at the load still has high voltage spikes. Hence, we increase the frequency of the PWM signal such that the voltage and current by the inductor remain somewhat stable. This is also the reason why the switch mode power supply uses high frequencies. To further smooth out them, we add a capacitor in parallel. This is a capacitor. Capacitor wants to keep the potential difference constant across itself, and for that it will change the current through it. As the switch closes, the voltage increases to 5 volts. To resist this, the capacitor flows current through itself, raising the other terminal to 5 volts. This is possible due to the electric fields which are generated in the capacitor. But it can't flow current for a long time as the plates get charged, thus the current reduces, and voltage at the other end starts dropping to the ground. Also, the capacitor starts storing the energy in its plates. After some time the plates get fully charged, thus no current can flow, and the capacitor acts as an open switch. Now, if you open the switch, then there is no source to supply voltage and thus voltage starts falling. But as you know, voltage across the capacitor cannot change instantly. Hence, now the capacitor acts as a battery supplying current. But it slowly runs out of energy and thus the flow of current reduces, and after some time it stops, thus the voltage drops. And we have created is the buck converter.
तुमने अभी मुझे जाना ही कहा है। मैंने कई देश और
But there are some issues, as the load changes, the voltage across the load also changes, so we need to create feedback to change the duty cycle of the PWM signal with respect to the load. Also, how is this PWM signal getting generated? This is the complete circuit. The voltage at the output is reduced by a voltage divider and it is fed into an op-amp which acts as an error amplifier. This component is known as an operational amplifier, or an op-amp in short. It has 2 inputs and 1 output. The other 2 terminals are for the supply voltage. It is used to amplify the difference between the inputs. It compares both the input. If the voltage at the non-inverting input or the positive terminal is greater than the inverting one, then the output is the positive supply voltage. Or, if the voltage at the inverting input or the negative terminal is greater than the non-inverting one, then the output is the negative supply voltage. In this configuration, the op-amp wants to keep both of its inputs at the same voltage, and for that, it will change its output. As the feedback is to negative input, the output varies according to the voltage at the negative input. This can be seen as a seesaw. When the input voltage falls, the output rises. And when the input rises, the output falls. This is how the differential amplifier works. This is a triangle wave generator. The output of the error amplifier and wave generator is fed to another op-amp which acts as a comparator and outputs the PWM signal, which controls the MOSFET. Here the negative input is a constant voltage from the differential amplifier and the positive input is the wave from the triangle wave generator. Hence, when the triangle wave is higher than the constant voltage, the output is the positive supply voltage. Here it is plus 5 volts. And, when the constant voltage is higher than the triangle wave, the output is the negative supply voltage. Here it is ground or 0 volts. This is how the comparator works. If the constant voltage increases, then the width of on time decreases, and if the voltage decreases, the duty cycle of PWM also decreases. This is a P-channel MOSFET. An N-channel MOSFET will turn on when the gate voltage is above the source voltage, and a P-channel MOSFET will turn on when the gate voltage is below the source voltage. So when the PWM is high, the MOSFET is off, and when the PWM is low, MOSFET is on. Hence, the duty cycle of PWM and MOSFET are opposite. As one increases, other decreases. But you may think, why not use an N-channel MOSFET, because it is on when the gate voltage is high, and off when the gate is low? Because the voltage at the gate required to turn on the N MOSFET should be higher than the source voltage, and during operation, the drain and source voltage will be almost the same. Thus we need higher than VCC at the gate to turn on the MOSFET. Hence, we use a P MOSFET. Also, we add a pull-up resistor between source and gate. This is the positive supply from the battery. These voltages are created with the help of voltage regulators. As these voltages are used only for references, thus there is no current drawn from them and no power is lost. In real cases, due to non-ideal components, some power is lost as they draw a small amount of current. Now, let's look at the working of the complete circuit. We will have an input voltage of 12 volts, and we want the output of 5 volts irrespective of the load. Now, if we increase the load, the current increases, but the PWM is the same as before, hence the voltage falls. This causes the voltage at the reference to fall and thus increasing the difference between this and reference at the differential amplifier. This increases the voltage at the output and then the duty cycle of PWM decreases from the comparator, thus increasing the on time of MOSFET and increasing the voltage at the load. Also, we can change the voltage by changing the value of the potentiometer. This change in resistance will affect the feedback voltage, thus it will change the output of the error amplifier and then change the PWM signal. Now, while designing this, some care should be taken. First, the voltage at the error amplifier should always be below this reference voltage.